Today we are going to see about the Brayton cycle. Brayton cycle, otherwise called Joule cycle. So Brayton cycle is a power cycle in which air is used as the working fluid. Now we can see that it consists of four processes. The first one is isentropic compressions, that is 1 to 2. Then 2 to 3 is constant pressure heat addiction. Then 3 to 4 is isentropic expansion. Then 4 to 1 is constant pressure heat rejection. So in this process, 1 to 2, air is compressed isentropically. So from the PV diagram, we can see that the volume get reduces. That is from V1 to V2. Whereas the pressure increases from P1 to P2 as it is isentropically compressed. From the TS diagram, we can see that the temperature increases from T1 to T2, T1 to T2. Then, as it is an isentropic process, the entropy is constants. That is S1 is equal to S2. Now, the process 2. It is a constant pressure heat addiction process where the volume increases from V2 to V3. We can see that from the PV diagram, that is volume increases from V2 to V3. Then pressure remains constant as it is a constant pressure heat addictions. The pressure remains constants, that is P2 is equal to P3, where the temperature increases from T2 to T3. The temperature increases from T2 to T3. Then the entropy increases from S2 to S3. The third process is isentropic expansions, that is 3 to 4. In this isentropic expansion, whereas volume increases from V3 to V4, pressure reduces from P3 to P4. That is very clear in this PV diagram. The pressure get reduces, then temperature also reduces as the temperature and pressure are directly proportional to each other. So the temperature also reduces from 3 T3 to T4, right? So entropy remains constant, that is S3 is equal to S4 as it is expands isentropically. Then 4 to 1. 4 to 1 is constant pressure heat rejection. So the volume get increases, the volume get reduces from V4 to V1, then pressure reduces from P4 to P1, then temperature also reduces from T4 to T1, and entropy also decreases. So heat is supplied at constant pressure, that the mass is equal to 1 kg. That Qs is the heat supply. That Cp into T3 minus T2. This is heat equation. Clear? Heat equation. That is M into Cp into delta T. So M is 1 kg. So M is 1. So Cp into Cp means that is at the constant pressure heat is being added. The specific heat of the substance is Cp. So the temperature difference is T3 minus T2. This is heat supplied to the system. Whereas heat rejection is M into Cp into T4 minus T1. That is change in temperature. That is T4 minus T1. T4 is the maximum temperature and T1 is the minimum temperature. As mass is 1 kg, so Cp into T4 minus T1. Work done is heat supplied minus heat rejections, right? That is Cp. We are going to substitute the value of Qs and Qr. That is Cp into T3 minus T2 minus Cp into T4 minus T1. The efficiency of the cycle is work done by heat supplied. Okay, the work done by heat supplied. So substituting these values, we will be getting, finally we will be getting 1 minus T4 minus T1 divided by T3 minus T2. This is equation 1. In the process 1 to 2, that is PVT relations for this isentropic compression is T2 by T1 is equal to T2 by T1 is equal to T2 by T1 is equal to P2 by P1 to the power of gamma minus 1 divided by gamma. Okay, this is PVT relations. This you will be studying in the thermodynamics. Clear? Then from this we are going to find out the value of T2. T2 is equal to T1 into, that is P2 by P1 to the power of gamma minus 1 divided by gamma. Whereas P2 by P1 is the pressure ratio, which is denoted by R suffix P. Okay, now the T2 value is T1 Rp into gamma minus 1 divided by gamma, where P3 is equal to P2, where P3 is equal to P2 and P4 is equal to P1. That we have seen from the thermodynamics diagram. Okay, now similarly, we are going to find the value of T3, where T3 by T4 is equal to P3 by P4 to the power of gamma minus 1 divided by gamma, where P3 is equal to P2 and P4 is equal to P1. So we are going to substitute the value of P3 as P2 and P4 as P1. Okay, so we will be getting, as we know that already we have seen that P2 by P1 is Rp. Okay, so substituting that value, we will be getting T3 is equal to T4 into Rp to the power of gamma minus 1 divided by gamma. Okay. Now substituting the value of T2 and T3 in this equation 1, we will be getting T4 minus 1 minus T4 minus T1 divided by T4 into Rp to the power of gamma minus 1 divided by gamma minus T1 Rp to the power of gamma minus 1 divided by gamma. Now I am going to take this in this denominator. I am going to take Rp to the power of gamma minus 1 by gamma outside. Then we will be getting T4 minus T1 in the denominator. So both numerator and denominator will be having T4 minus T1 divided by T4 minus T1. So we are going to cancel that. Finally, we will be getting the efficiency of Brayton cycle as 1 minus 1 divided by Rp to the power of gamma minus 1 divided by gamma. So this is in terms of pressure we are calculating. In terms of volume mean 1 minus 1 divided by R to the power of gamma minus 1, where R is the compression ratio. So this is what we are going to say, how this is how we are going to calculate the efficiency of the Brayton cycle. Clear? Stop recording. Or இப்போ போடு, அது ஓடுதா பார்ப்போம். ஒரே அதை மட்டும் எப்படி அது முடிச்சா இது ஆப்ரேஷன் பண்ணிட்டேன். நீ காசு அதெல்லாம் சாயங்காலம் போல காமிச்சிருக்கேன். ஒரு இதில் ரிவ்யூவில் ஒரு எந்த பண்ணுறல எந்த மீட்டிங் பாரு